Select the major product of the following reaction. So we can see that our starting material contains a benzene ring, and it also contains an alkene, and we're reacting this with hydrobromic acid. So we have seen previously that hydrobromic acid can add to alkenes. It will not add to that benzene ring. So we're going to start the reaction as we've done in the past with our alkene reacting with the HBr. So I'm going to redraw the HBr here. And we know that our alkene is a nucleophile. The hydrogen of the hydrobromic acid is an electrophile. So the alkene will grab that hydrogen and we will break the hydrogen-bromine bond. And so the question that we have to answer now is, where did this hydrogen add? Did it add to this carbon or did it add to the adjacent carbon? And so at first glance, we might think, well, we're not going to get any selectivity here. We know that a carbocation is more stable if it's more substituted, but these are both secondary carbocations, or so it appears. Let's go ahead and draw those two carbocations and take a look and see if there's anything that distinguishes them. So first I'm going to draw a carbocation here, and the next one I will draw will be on the next carbon over, so depending on where that hydrogen adds. So we could potentially form this secondary carbocation, or we could form the secondary cation on the other carbon. So these are both secondary. And then we want to look and say, okay, is there anything that could make one of these more stable than the other? And hopefully we're paying attention to this benzene ring, and we see that this cation is on the adjacent carbon. And so that means that we've got some resonance stabilization here. So this is not just a secondary carbocation, this is a secondary benzylic cation. And so that means that this is going to be our more stable carbocation. So now we know how this protonation will occur. We're going to add a hydrogen to this carbon atom so that we end up with the benzylic carbocation. So there's that benzylic carbocation. And then we've also got bromide ion in solution. And that bromide ion is a nucleophile. The carbocation is, of course, an electrophile. And these two can react. So we're going to end up adding that bromine to that benzylic carbon. And that means that our product will be C.